Hey guys, this tutorial is going to be all about avoiding UV unwrapping. I'm going to talk about 3 different renders here. I'm going to talk about my weapon of choice, Octane. I'm going to talk about Redshift, and I'm also going to show you some neat little tricks in the C4D standard renderer. So let's have a look at what we're going to do today. First of all, I'm going to have a look at Octane and how to set up the Triplanar-Mapping. This is a method which lets you avoid UV unwrapping in most cases, I would say, by projecting a texture from different sides on your object and blending the edges together. I'm also going to show you how to use the Triplanar node in conjunction with Displacement, because there's a little catch that you can avoid. And I'm also going to show you how to map decals onto your object without the need for UVs. Then I'm going to show you in Redshift renderer how to set up the triplanar mapping, just basic settings, how to set it up in general. And then we are going to have a look at the good old C4D standard renderer that doesn't come with triplanar, but there's a method how you can set it up yourself. So stay tuned and let's get going. All right. We have this little scene here with this test object. It's just a little logo cut out here, and we want to project our texture here without using UV mapping. So how to do that? Well, first of all, I'm just gonna create a basic Octane glossy material and gonna open up the node editor. And of course, I'm going to need a texture that I can use here. So I'm just gonna drop in this little fabric texture from the other screen. That's just a basic texture that I got from textures.com. You can see it here on the right. And first of all, I'm just gonna plug it into the diffuse here, and then I'm gonna drop the material onto my object here. Well, here we are lucky. I've already UV mapped this, so it doesn't look too bad, but let's just pretend we don't have this here at all. So this is not working very good, as you can see. So to avoid this, we can just use the triplanar node here, which is on the left here at this kind of reddish area, and it's this node here, triplanar, which comes from 3 different planes that are used to project the texture on your object. So to use it now, I'm just gonna plug this in, maybe here into the second input, so I can explain you what it's doing. And you see this input here is called X minus, and the other ones are called X plus, Y plus, and so on. This corresponds to the object axis in this case. So we have X facing from left to right, Y facing from bottom to top, and Z from left to right. And this is the way that the triplanar is mapping your texture, the direction that it's using. So using X minus would mean negative X axis, so everything that's facing to the left. So this corresponds with the normals of your surface here. So by using the X minus input here, we now should see our image on every angle, on every surface here that is angled 90 degrees to the X axis and facing to the left. So let's just try this out. And to use the triplanar properly, we also have to set up a projection node here, which we get by just clicking the image texture node and going to projection. And then in this little node, we're going to set the texture projection to triplanar. Now to control the size of everything, we just go again to the image texture node and set up a UV transform too. And now we can see that it's already working as it should. So every surface that is angled to the left, that it's facing in negative X direction, gets this texture now, but the texture is very much scaled up. So I'll just go to the transform node here and scale it way down to say 0.05. I think, yes, this is okay. So now we have set this up. Of course, in many cases, you would just want to set up your texture facing in every direction at once. But of course, you could also set up, if you wanted, 6 different textures here. To use the texture in every direction equally, you don't need to connect every input here. You can just use the first input, disconnect the second one again, and then just activate single texture in the triplanar node. So then every other node here, every other input gets this value from the first input, so your image is projected in every direction at once. Of course, you can also set up the coordinate space to world, so we don't use the objects axes to project our images, but instead we use the world coordinate system, which is fixed, as you know. So if we were to animate our object now, the projection of the texture stays fixed and it doesn't move, and it looks like we maybe would have set up a beamer that is projecting the texture onto this object here. So maybe a neat little effect. I don't need it here, so I'm gonna set it back here to object coordinate space. Okay, obviously this doesn't look very good, but it's, I think, fine to demonstrate how the triplanar is working. So just to sum it up, get your triplanar node here, set it to single texture. If you want to use just one texture on every surface, other than that, you could just plug in all the other textures here into the other input nodes and set up a texture projection node to triplanar, so this is all mapped correctly. If you don't do this, you might get some strange projection errors, and use a transform node to scale your image the right way, because in most cases, at least for me, the textures are going to be projected way too big, so we need this transform node to just scale it down the way we want to. Okay, so this is how to set the triplanar in general, and in the next step I'm gonna show you how to use displacement together with triplanar. Alright, so I've resetted everything so we can start from scratch and everything can be fastened to your memory a little bit better. So I'm gonna redo the steps that I've did before. I'm gonna create a new material. I'm just gonna set up a basic color and roughness so everything is calculated very fast so we can see what we are doing here for the tutorial. And I'm gonna go into the node editor now, and first of all I'm gonna need my displacement texture. I'm just gonna get this very quick here from my other monitor that you cannot currently see. Now I've found it. This is my texture. You can see it here in the little thumbnail preview. And I'm gonna set up the triplanar again. I'm gonna connect it here to the X+ input and activate single texture here. So it's displayed on every axis, and I'm also going to set up the projection and the transform node again, set the projection node to triplanar so that everything will be mapped correctly. Now we could already activate the displacement node here, but I don't want to plug it in for now because displacement is always kind of a heavy thing to render, and I don't have much control about how everything is looking if I just plug it in at this point. So to get an easy preview on what will be happening with our material here and with our texture, I'm just gonna drop it into the diffuse channel here. So now I can see the black and white of the displacement texture and set it up as I want to before plugging it into the proper node here. So we see this is way too big. I'm gonna go to the transform node and scale this down to say 0.05. Well, this is still too big. 0.03. This is okay, I think. And I only want to have the texture one time on each side and not like this, not tiled. So I'm going to go to the texture node itself, go to the border mode, and here I have different settings that I can use, and I want to use the white color. So this means I only have the texture one time on each side and the rest is filled with white. So everything stays exactly the same. I also don't want it to be on those front faces here, so I'm gonna have to undo the single texture option here in the triplanar, and I have to connect it manually to these inputs here. But which inputs to choose? Well, the triplanar is set to the object mode here, as you can see here in the transform settings, coordinate space object. So this means those axes that I can see here are the ones that the triplanar is using, and I don't want it to be using the blue Z axis here, which is facing to this forward facing polygons here. So I'm just gonna use X and Y and not use Z, and to be sure that everything will be mapped correctly, I'm just gonna use a white totally white 100% RGB spectrum node here so that I know which way the top side is looking here. Now everything is white except my logo here on those 4 sides all around this object, and this is what I want to have, so I can disconnect it again here and plug it into the displacement. And as we see, we don't see anything because unfortunately, at least in the version I'm using the latest Octane release as of 16th February 2021. So there is no texture displacement possible with the triplanar node. But however, vertex displacement is possible, and that's the node that you need, the type here of displacement. But first of all, I'm just gonna change the level of detail because I'm using a 1000 by 721 texture. This is not very high. Obviously, you would need much higher resolution for very good displacement. But since I at least have those 1000 pixels here, I'm gonna increase my level of detail to say 1024 by 1024 so that Octane uses the texture in all of its resolution. So now I'm gonna activate the vertex displacement, and you can see the displacement happening. It's not the thing I want here, so I'm gonna reduce the height to say 0.5 centimeters, and I can see my logo being embossed here, but I'm gonna go to the default camera. As you can see, this is not looking very good. We just have polygons are flying all around here, and this is because now, as I said, it's not texture displacement, it's vertex displacement, so it's working, so to speak, with the real polygons, and the resolution of the mesh is way too low to get this fine structure here. So first of all, what we can do, we can increase the resolution of our subdivision surface here. So if I go to object, I can play with this setting, but it's already set to 5, so this is a really high value. I don't even know for sure if this has a very strong impact on the result that Octane Render gives you. However, you also have this subdivision level here, and this is the lever that you can engage, so to speak, to increase the resolution here and to improve your result. But a word of caution, this massively increases your VRAM usage, so don't overdo it. Only go in small increments of 1 and try what's working for you, because it might crash Octane if you are using a value that's too high and it overflows all your VRAM that you have available. I'm also gonna use this mid-level here and set it from 0 to 1, so I'm not bloating up all the geometry here, and the object itself stays as it was, and it's only embossed here on the side. So I'll try a subdivision level of 4. However, I've tried a level of 5 in a previous attempt and it crashed my Octane. So for me at least, it won't get better than this. If you have maybe a new RTX 3090, you're gonna have a lot of VRAM and can of course use this. So to sum it up, this is not a method you want to use for very detailed displacement. And as you can see, this logo is it's flipped from left to right, so I didn't consider this when setting this up. I would have needed another transform node here so that it's displayed the right way. It's here on this side, I think it's correct. No, it's well, okay, you have a little bit of control here by using this transform node. That's how you can control the projection of your displacement texture, but by using the vertex displacement, it's not possible to use very fine structures. So now it's displaced correct. You could also see how long it took Octane to update the scene, because all the geometry had to be loaded into the VRAM. So yes, use with caution, but it's possible to use with triplanar, and if your scene allows it, so like this, if you're far enough away, then this definitely works, and I think it's a quick and easy method to use. So next step, we are going to have a look at how to map decals on our geometry without the use of UVs. So as you can see, I've switched scenes so I can demonstrate what I'm I want to show you with this MIDI controller. You can already see some decals applied on these buttons here. You can see the text written on them. You can also see it over here. And what's missing for the moment is this logo here and all the rest of the text for all the other buttons. And I'm going to show you how you can set this up without using UV unwrapping, which could be handy if you, for example, have a CAD object which tends to be very tedious to unwrap, or you just don't want to unwrap your model. Then you can use this method here. So first of all, how do you get this texture? Well, I've just used a basic rendering with C4D standard renderer from the top here and saved this. So just set up your camera to a position where you can look in the same direction as the decals would be facing later on, and render this really basic without beautiful settings or something. Just quickly get this render. Have a look that you're setting your camera up correctly. Don't do it by hand. Use the coordinate manager and set it up really 90 degrees to the surface so you don't get any distortions. Then you, as I said, can save a basic image and use, for example, Photoshop to create a new layer where you would enter all the text or the decal stuff. I don't know, whatever you want to put on your object. If you then have saved your texture, it might look like this here, for example. You can see all the elements here that are going to be visible on my object. So that's the texture I'm working with. And now we're gonna use it in this scene here. So to do this, I'm just gonna create a new material here. Go to create new glossy material. However, you can choose whichever material you like, but I'm just gonna use a glossy one here. I'm gonna open up the node editor, and it's just one simple step. I'm just going to use this texture now and drop it in. So here's the texture. I'm just gonna drop it in, have this image texture node here, and connect it straight to not the diffuse but the opacity. So now this material, which would have been all white, covering the whole object in white, now only covers the object where this texture is white, and where it is black, it's not applying this texture. It's basically just an alpha mask. You might know this from Photoshop. So just make this connection here and you're almost done. Go to the image texture node and set the border mode to black color, so you don't get a tiled texture, but rather just one single texture that is applied at the center of your material, at the center of your object. And now we are almost ready with setting this all up. If you want to change the text color, you can of course set another diffuse color here, which will then be masked with this texture here. Or if you are using a real decal, so to speak, like a logo of something or an image, then you would of course have to plug the alpha channel into the opacity and the regular RGB image into the diffuse here. Okay, so now that we have set this node system up, which is really super basic, we can just drop this here onto our existing object and be sure to set this material to the right of the already existing material. Then select the material tag and go down to the projection and set it to flat. This will just flat project our decal onto the object without distorting it in any way. And we can already see things happening here. But this is not what we want. And it's looking like this because if we change the mode here to the texture mode and zoom out a little bit, then we can see the way our material is mapped here. And it's mapped along the Z-axis, so it's only mapped here onto those forward-facing polygons, which we don't want. We want to have it mapped from the top. So just select the material tag, go down to the attributes manager, and by using those coordinates here, just flip it on the side so that the Z-axis is facing onto to the surface where you want your texture to be projected to. So now we can see the first characters here appearing, but as you can see here, this texture plane is really big, so it's not working with the size of this model here. So just to see what's happening here, I'm gonna reduce the size at first to just 10 by 10 centimeters, and now we can see our text appear here, and we can also see that it's facing from left to right. This is not what we want. We want it to be facing this way, so we have to turn it 90 degrees. I'm going to use the H angle here. So I have 90 degrees H and minus 90 degrees P. So this is working for now, but now the size is not correct. It's important that you have it in the middle of your object. In this case, for your case, it might also be that you have to move it to the left and to the right, or up or down. You can use this position coordinates for this to position your decals. But in my case, since I've used the approach that I've just shown you with rendering out this image first, everything is perfectly centered and should be working with the texture being placed here in the middle. But it depends on your project. But this question aside, how would you determine how big your decal has to be? Which centimeter values do you have to enter here to get the right proportions? Well, go back to your original texture that you made in Photoshop. You might have already asked yourself which size value you should have used in Photoshop. Well, this doesn't matter so much. You of course should choose a value that is high enough so it looks good in your final rendering, especially on close-ups. But you can set this value, yes, so to speak, however you want. In my case, it's 1920 by 3200 pixels. And what's now very important is the word aspect ratio. So for the moment, I've just set this here to 10 by 10 centimeters, which would be square. But obviously 1920, sorry, by 3200 isn't a square image. So you have to maintain this aspect ratio. And I'm just gonna quickly explain this here for the ones who find this difficult to understand. Here on the left, the orange square, this is 1920 by 1080 image. And so this has an aspect ratio of 1.77 if I divide 1900 by 1000. So here the blue plane, this has a width of 1200. And now to make it have the same aspect ratio, I need to multiply this dimension here, the 1200, by this value here, by this aspect ratio. Or well, in this case I have to divide it, so I'll divide 1200. Let's quickly do that here. 1200 divided by 1.77 gives me 677. So this is this number here. That's just not very accurate. I should have divided it by 1.7777 because this is a periodical aspect ratio, and so we get to the 675. So you always have to maintain this ratio to make it appear correct. So if you're making this plane bigger here, then of course you also have to change the Y size in the same manner. I hope this is clear. So the left plane here, this would be our original texture. So here we have pixel values here on the left, and on the right we want to have centimeter values. So first of all, we have to calculate the aspect ratio of the pixels and then use it with the centimeter values here on the right. So going back to our actual project, we had this texture here where we have 1920 by 3200. So I'm just gonna divide this. I'm gonna divide 3200 by 1920, which gives me 1.66666. So now I can go to this texture here. And if we have a look at the axis here, you see this green Y-axis. So that's the value we need to change for the width here. So if I, let's say, increase the Y value to 20, I make this texture appear wider. So this has to be the long side of everything. And how to get this value in the first place? Well, we can just have a look at our model itself. If we go here to the model mode again, and if we select our polygon model here, then we can see down here that it has a size of 31.2 centimeters. So we have to divide this by 2 to get a reference value. So we can just go to our material tag again, go to the Y value and enter the size of our model, 31.2, divide this by 2, and then we get a rough estimate. This won't work 100% unfortunately, but we can get, as I said, a rough estimate to start with. So now we have 15.6 centimeters for the long side, and we've just calculated our aspect ratio of the original texture to be 1.66666. So the short side of our material projection here needs to be this length divided by 1.66666. So I'll just write 15.6 divided by 1.66666, and then I'll get 9.36. And what you can now do, you can just try and play around with these settings here and use this, or you can also try and play with the scale tool, although I don't like to use it that much because sometimes I had problems with it, but in this case I think it should work. So you can just use this little triangle here to make it scale evenly along both axes and just get those final last percents of scaling that you need to change it. But well, now I didn't want to do this. I scaled my model. This was of course wrong. I have to use the texture mode here. So now I have to use the blue triangle in my case, and now we can see if this is going to work. Well, this seems to work quite okay, but I personally I'm not the biggest fan of this tool for materials, but you get the point. So I'm not gonna bother you having to watch me trying to fiddle out the last percents here, but I think you get the idea. So you just have to play with those values. Probably you won't be able to maintain the perfect aspect ratio in a complicated case like this, so you maybe just have to cheat a tiny bit, but as long as you don't change up the values too much, nobody will notice that it's not the perfect original size like the texture that you've used. So I think like this here, it's already looking kind of right. Maybe needs a little bit tweaking to get it to the perfect size. As long as you're only using 1 or 2 decals, or having like this, the buttons that only have one single decal that can be centered in the middle, then this will be very easy for you. All right, so let's have now a look at how to set up triplanar mapping in Redshift. Alright, so let's see how we can set up the triplanar mapping in Redshift. I've got my old example scene back here, but just with a little Redshift dome light environment, and that's it. And we see our example object without any material. So first of all, I'm going to go to Redshift materials, and I'm just gonna create a default Redshift material and drop it onto my object. It's not very visible because everything is gray. We can change this by set up another diffuse color here in my material. So now we see, okay, this material seems to be active, but we don't have any texture right now. So I'm gonna change that. I'm just gonna switch over to the other screen that you can't see at the moment, and I'm gonna drop in this material. No, I don't want to save it in the project folder. I want to leave it where it is. And now we have our texture here, and we could now create this input here, the diffuse color input for our Redshift material, and do this connection, and we could see a change, but this is not what we want because this is obviously not triplanar mapping. This is something else. So I'm gonna just go here to the left and enter triplanar in the search tab, and now we just need to set the triplanar between our material and our texture. So just go to the output color of your texture and connect it to the input area here of the triplanar node, and then you'll get the little drop down menu and go to texture image X, that's the one you want. And now, like with Octane, you can activate same image on each axis, so you only need to set this up once for this single texture. And now we have our output color here, which we can connect to the diffuse color input of our Redshift material, and we can already see that it's looking a little bit better, but still not the way we might want to have it. So we go back to the triplanar mode, and in contrast to Octane, we don't need another node here for the transformation. We can just set this up inside of our triplanar. And the other difference to Octane is in Octane you would reduce the number to reduce the scaling. In Redshift it's the other way around. If you want to have smaller tiles, you have to enter a bigger scaling factor here. So if I set this from 0.01 to just 0.1, you can see the tiles are getting a lot smaller, and I have my material set up here. So in your case you would just have to play around with those settings to get the look that you want, but overall the triplanar tends to make everything appear very big, so you need small scaling values here. As with Octane, you can also set another projection mode. For example, you can set this to world, which we've already had a look at in Octane. So now the projection is locked to the world coordinate system, and if I rotate my object here, it looks like as if the texture would be projected with, say, a beamer on it, and it doesn't move at all. You might use this for a little effect, I don't know. I've never used it in a project, so I'll just stick with object, so then the texture is bound to my object and will not move. So that's the triplanar mapping for Redshift. You can of course also change the blend amount here and the blend curve. This has to do with the edges. Just play around with those values to see how they can help you. In the most cases I've never touched them, but they control how the blending from one side to the other is happening. So to sum this tutorial up, we will now have a look at the Cinema 4D standard renderer and how to create our own triplanar setup there, although the C4D standard renderer doesn't have it, so we need to help ourselves. Okay, so here we are now in the Cinema 4D standard renderer. So if I render this, I don't see anything. So I'll just activate the default light here under the render settings. Like as I said before, this does not have to look very fancy, it just has to work so you can understand the principles behind everything. So as we don't have a kind of an interactive render window as we are maybe used to have from Redshift or Octane, we can use this preview region here, interactive render region, which is basically the same. It's not that fancy, it's just a little region that you can set up in your viewport here, but it does the job. So I'll just set this up so you can see what's happening. So we will now create a new material, drop it onto our object here and open up the material editor. And now you can use the channel that you need. I will just use the color channel here and go to the texture and set up a layer shader. So now everything is black because we don't have anything here inside our layer shader, but what I'm gonna create here is a new shader and use effects fall off. And this fall off works with our object's coordinate system. So if I click on this fall off, I can see the space is object. I can also set it to world or to camera, as we already have seen for Octane and Redshift too. So now we have set it to object and you can see the direction here. This is a vector and the vector is X, Y, and Z. So these are our object's axis. So if I wanted to have this Z axis here, the blue one, I would just enter 0, 0, 1. So now you can see that the top side got black. That's because we have this gradient here, and the right end of the gradient is the positive direction and the left end is the negative direction. So we have set up this vector here. It says 0, 0, 1, which means positive 1 in Z direction. So this vector is pointing in the same direction as this blue arrow here. So as I said, the gradient goes from left to right, and left means the negative values. So this would be every polygon that is facing in the opposite direction of this vector here, which is the reason why this top side of the object here got black. So if we switched this, for example, it would become white. So what we want now is that everything facing in the same direction gets white, and everything that's facing in the different direction gets white too, and everything in between shall be black. So how can we do this? We know left is negative direction, right is positive direction, and everything in between would be an angle. So if you're, well, let me just set this up really quick. We have this cone here, for example. That's the vector that we just set up. So now if I focus on this green arrow here, this is facing in the same direction. This would be positive. This would be the right side of this gradient. And now while I walk along this gradient, so to speak, this angle is changing and this arrow is turning, so to say. So 90 degrees would be the middle of this gradient. This would be 50%, and facing even more into the opposite direction of this cone of our vector would be the left end of the gradient. So this would be 0%. I hope this made some sense to you. So going back to our gradient here, our fall off, we know this means 180 degrees, this means 90 degrees, and this means 0 degrees. So we want it to be white at 0 and at 180 degrees, and everything in between shall be black. So I'm just gonna set this up real quick. I'll just leave a margin of around 15% on the left and on the right side, and set up those stoppers here, or those knots as they are called. So now we see everything is black except the top side and bottom side. So if I leave this camera here and look from the other side, we can also see that these elements are white. And we can see this edge here, and everything beyond this edge is projected as black. All right, so now we can set up the same system again. I'm gonna call this one fall off Z, and I'm gonna right click on it, go to copy shader, and then I'm gonna click here on the shader button and go to paste shader. And I'm gonna deactivate the visibility of this old fall off, and I'm gonna call this new fall off Y. Just gonna click on it. The gradient is already set up, so I only have to change this vector here at the top. So I'm going to change it from 0, 0, 1 to 0, 1, 0, which would be the y-axis. So we can check if this is working, and this seems to work. We see in green the y-axis arrow, and the top is white and the bottom is white too, and the rest is black. So this is also working. And now we can go to the shader button here and paste this one again. Also make only this shader visible, everything else invisible. Go to the settings and again change this from 010 to 100, so only the x-axis is now activated, and we see only polygons facing in x direction, both positive and negative, are being displayed as white, and everything else is black. So now we have fall-offs in every object direction, and we can drop in textures. So now I just have 3 textures here. As you can see, I have this art deco floor, I have this fabric here, and I have this UV test texture, this checkerboard. And the only thing I need to do now is just set them up to the axis I want them to be displayed on. So this UV grid here will be displayed in X direction since it's on top of this fall off. The fabric will be projected in Y direction and so on. And the last step to do is just go to this mode here and change it from normal to layer mask. Now do this for all the other ones too. And I think this is not working all that well because I've not done the final step. The final step would be to click on this material tag, go to the attributes and set it from UV mapping. Of course, this won't work. We need to set it to cubic mapping. So that's it. And you can now see what's happening here. I'm going to get rid of this interactive render region and instead just use the regular render command. And as you can see, we have 3 different textures now. They don't look very good because especially they are very stretched out. I can control this by the tiling here in the material texture. I'm gonna just up the tiling here to say 8 in each direction. So now this looks a lot better, and I can see my UV grid being displayed in X direction, my Art Deco floor in Z direction, and the fabric here in Y direction. So this is how you kind of fake triplanar in the Cinema 4D standard renderer. And the nice thing is, because we are using this fall off here, this layer with the smooth shading, we have this soft transition at the edges. So if I render this, you can see here how it's blended together, and if you wanted to have more control about this, you can change this gradient here. Of course, in comparison to Octane and Redshift, this is a very elaborate process, but it's still possible even in this little standard renderer here. I hope this tutorial helped you. The next one I'm gonna do is about unwrapping a hard surface model using the Cinema 4D UV tools. So if you don't want to stick to triplanar mapping and do the proper UV unwrapping and texturing, then stay tuned for this next tutorial, and I hope I'll see you then. Bye bye.